Okay, so similar to multiplying powers, there are rules to follow when you are dividing powers. Pretty similar though. Remember when we multiplied powers together, we added the exponents? Well, the opposite follows for division. When we are dividing powers with the same base, subtract the exponents. So, for example, x to the fourth divided by x squared, we're just going to do 4 minus 2. That's 2. So x squared. X to the second power. Okay, so just subtract the exponents. And if you have more than one variable, just make sure you only subtract the ones that have the same base. So here, x to the seventh divided by x to the third, 7 minus 3, that's x to the fourth. And then move on to the y's. 2 minus, there's a 1 there, so 2 minus 1 is 1. So just y. You can put the 1 on there if you want to, but you don't need to. Now if you have coefficients, the numbers in front, just divide those like you would normally. And if you can't divide them, like 6 divided by 18, well 18 doesn't go into 6. What you're going to do is just leave a fraction. So 6/18, that reduces to 1 over 3. And then move on as normal. So we have x over x, x divided by x. Those will just cancel out because 1 minus 1 is 0. So the x's are actually gone. Y to the 7th divided by y to the 5th. 7 minus 5 is 2, so that's y squared. And then z to the 5th divided by z to the 1st. 5 minus 1 is 4. So z to the 4th. Looks a little messy, so I'm just going to clean that up. Y squared z to the 4th all over 3. You don't need the 1 in front. Just like any variable, you can leave the 1 off. So just leave it like this. So if you have coefficients out front, you can just reduce the fraction. 6/18, that's 1/3. Now if the larger exponent is in the denominator, that's where the power ends up. Okay, so far we've had all the powers end up in the numerator, but if the larger one's in the denominator, that's where it's going to be. So here we have m to the 7th over m to the 9th. Well, the difference is 2. 9 minus 7 is 2, but because the larger one is in the bottom, the answer is 1 over m squared. Because what's really happening is you have 7 m's in the top and 9 in the bottom, and they're all canceling out except for 2 of them, which is why we have 1 over m squared as the answer. Okay, 2 left. 8 divided by 2, well that's 4. So what I would do is, for these bigger problems, I would just, make your fraction bar, put the ones you know where they go, and then you can clean it up at the end. So 8 divided by 2 is 4. X to the 7th, and then we have x to the 3rd. 7 minus 3 is 4. But again, because the bigger one's in the bottom, that's where the answer ends up. So x to the 4th. If I can actually write a 4. Okay. Y to the 1st divided by y to the 3rd. 3 minus 1 is 2. The bigger one's in the bottom, so that's where that goes. And then z to the 5th divided by z squared. 5 minus 2 is 3. Bigger one's in the top, so that's where it stays. Z to the 3rd. You can leave it like that. 4z to the 3rd over x to the 4th y squared. So wherever the bigger exponent is, that's where the power ends up. Last one here. Here we have to do 2 things. First, we have to square this top thing and cube the bottom thing, and then we'll simplify afterwards. So 3 squared is 9, and then multiply the exponents. So x to the 4th, y squared, z to the 8th. Just multiply each exponent by 2. 2 times 2, that's 4 for the x's. 1 times 2 is 2 for y. 4 times 2 is 8 for the z. And on the bottom, we have 2 to the 3rd power. So 2 times 2 times 2, that's 8, not 6. Don't do 2 times 3. It's 2 times 2 times 2. That's 8. And then x to the 4th to the 3rd, 4 times 3 is 12. So x to the 12th. Y, 3 times 3 is 9. And then z, 1 times 3 is 3. Then we can simplify 9 over 8. That's going to stay 9 over 8. Can't reduce that. It just stays the way it is. Okay, x is 12 minus 4 is 8, ends up on the bottom. Y is 9 minus 2 is 7, also on the bottom. Z's stay on the top. 8 minus 3 is 5. Bigger one's on the top, so it stays on the top. So 9z to the 5th over 8x to the 8th, y to the 7th. Now, if these seem a little confusing, I just watched the video again, watch it a couple times until you see. But we are just subtracting the exponents on the same base. All right, so you've got 4 problems to do here, very similar to the more difficult ones here, but do your best, and if you have questions, send me an email.